Good morning, class. So I'm sorry I cannot be there today, but you get me anyway by way of YouTube. So let's go ahead and get started. Hopefully you've had this packet passed out to you and follow along, fill it in, and do the very best you can. We're going to do some verifying trigonometric identities, and your homework is going to be here on 1 through 15 on this page 650. Number 3 is a really icky question, so let's just skip that one. So as we're going to be verifying trigonometric identities, we should really kind of know what an identity is. I know I've told you in the past, but let's really look at the true definition of it so that we know what we're doing. So an identity is a true statement for all, and this is the very, very important part of this, for all values in the solution set. For the variable. Basically, what this boils down to is that if you're given an equation, that equation is an identity if it is always true, no matter what value the variable is assigned. So let's take a look at some things that are and some things that are not identities. So we've got a few equations here. Let's take a look at this first one. 7x plus 6 equals 8x minus 10. So I'm going to subtract 7x from each side. We get 6 equals x minus 10. Then we'll add 10 to each side. X equals 16. This equation has one solution. X can only be 16. If it's any other number, the statement is not true. So this is not an identity. Let's take a look at this next. Well, it's not an equation, it's an inequality, but inequalities can also be identities if it's true for no matter what value that x gets. So let's go ahead and solve this. We're going to go negative 6 on each side. We get 7x is greater than 4. And we'll divide by 7. We get x is greater than 4/7. Now, if we put that on a number line, it would look something like this. At 4/7, we'd have an open circle. And then it would be greater than, so we would shade it to the right, and it would continue on and on. Now, this has infinite solutions. Because it's infinitely going on and on towards the right, but it doesn't include all solutions. Or all real numbers even. So it is not an identity. Let's show you what an identity really looks like. We've got 7 times x plus 2 equals 7x plus 14. So I'm going to distribute this 7. And I get 7 times x is 7x. 7 times 2 is 14. And that equals 7x plus 14. Well, if it becomes the same thing on both sides of the equation or inequality, then this is an identity. because it is always true no matter what x is. Now, I gave you examples with simple equations. We're not going to be doing algebraic equations. We're going to be doing trigonometric equations. But before we jump into that, let's just look at what it means to verify an identity. So we're given an algebraic equation, and what we want to do is verify that this is a true statement. So we're going to keep solving, manipulating this until we get something that is equal to each other. So the first thing that I'm going to do is I'm going to factor the numerator. X squared minus 25 is the difference of squares. It can be factored into x plus 5 times x minus 5. And that's being divided by x plus 5. And it equals x minus 5. Now I'm going to cancel out some common terms. So the x plus 5 divided by x plus 5 is 1. 1 times x minus 5 is x minus 5. And that equals x minus 5. So we have just proved that this is true. It is an identity. Now to do our trigonometric identities, we need to have some tools. So let's give you some of these tools. Some of them we already know. So let's look at our reciprocal identities. You know this, that the sine of an angle, let's call it theta, and its reciprocal is cosecant. So it equals 1 over cosecant, as does the cosecant of theta equals 1 over the sine of theta. The cosine of theta is equal to the 1 over the secant of theta, as is the secant of theta is 1 over the cosine of theta. And our tangent is 1 over cotangent. And the cotangent, oops, my paper's wiggling, is equal to 1 over the tangent of theta. We have a couple other identities that we need to know. One of them you've seen before, but I really haven't done a lot of emphasizing on it, and that's the quotient identities. And those are that the tangent of theta is equal to the sine of theta over the cosine of theta. Right? Y over x. And our cotangent theta is equal to the cosine of theta over the sine of theta. Now here's some new ones though. We have not done Pythagorean identities in the past. So this is new to you, and we're going to use this one a lot. Sine squared theta plus cosine squared theta is equal to 1. Now there's a couple variations to that. If I were to take that same thing, sine squared theta plus cosine squared theta equals 1, and I divide that by sine squared theta in every term, sine squared theta divided by sine squared theta is 1. Cosine over sine is our cotangent, so that would be cotangent squared theta. And 1 over sine is going to be that cosecant, so that's going to be cosecant squared theta. So here's a variation of the Pythagorean identity. There's one more variation that you need to know. So if we start out with that first one, sine squared theta plus cosine squared theta equals 1, and we divide by cosine squared theta this time. Sine over cosine is tangent, so we have tangent squared theta. Cosine divided by cosine is 1. And 1 over cosine is secant squared theta. You know, I never remember these two. I can only get to them by doing the division, because then I know them. And that's using the Pythagorean, or the identities, the quotient and reciprocal identities that I just gave you. Now, these identities, the reciprocal identities, the quotient identities, the Pythagorean identities, you need to memorize. And we will have sometime in this unit a pop quiz. I won't tell you when, but we are going to have a quiz where I'll just say, hey, get out a piece of paper and write these down, turn it in. So get to know these. And that particular quiz, you're going to be able to take over and over again until you pass it, because you really need to know these. All right, so now that we have our tools and we know what verifying an identity is, let's go ahead and do a few verifying the identities so that you can see what in the world I'm talking about. So we've got the sine x cosine, or cotangent x equals cosine x. Well, I'm going to just write everything in terms of sine and cosine because I know how that goes. So I'm going to use sine x. Cotangent, looking up here, is the same as cosine over sine. So I'm going to go cosine over sine, and that equals cosine x. Well, remember, this is over 1. I can cross off my common terms, and I get cosine x equals cosine x. So, yes, it is an identity. By the way, none of these will not be an identity. You can always prove these or verify these. So that one is an identity, and I've just shown that. Let's go to the next one. We've got tangent squared minus secant squared equals 1. Well, up here, I know that secant squared is this thing. So I'm going to take, include the angle, that, and make it be tangent squared x plus 1. So I have tangent squared x minus this tangent squared x plus 1, and that equals 1. I do have a typo. I'm sorry. This is going to be a negative 1. It's a negative 1. Yeah, I did type that wrong. So I'm going to distribute this negative, and I get tangent squared x minus tangent squared x minus 1 equals negative 1. Well, tangent squared x minus tangent squared x is 0. So I have negative 1 equals negative 1. And I have verified that. Let's see if I can move this over just a little bit. There we go. So that you can see this side. All right, we have cosine cubed x plus sine squared x cosine x equals cosine x. So I'm going to work at this complicated side. I see that these two terms, this term and this term, have a common factor, and I'm going to factor that out of cosine x. And that leaves me with cosine squared x plus sine squared x equals cosine x. Well, the Pythagorean identity tells me that that is 1. So I have cosine x times 1 equals cosine x. Well, anything times itself is itself. So I have cosine x equals cosine x. There we go. So that's the type of thing that you'll be doing today in your assignment. So it is on eCampus, so you can get on your phones and pop that open and start working on this if there's time left in the last of this class. So good luck, and I'll see you later. Bye.